You will do this question and send the answer on my WhatsApp. Okay. Hmm. Yeah, I can see the concept, right? But I don't know about the calculation, Khalid.
I will calculate and let you know. Yeah, appearance of A. Okay.
Nabil Khan, I think you are going to attend on Saturday, Sunday, right? Yes, Nabil. हाँ, you can leave the class. आपको Saturday, Sunday वाले के लिए link मिल जाएगा. तब तक के लिए what you have to do, you have to watch that one lecture ना I gave you on WhatsApp. You watch that lecture if you have not watched it. Okay. On Saturday, you will get a link to join the class. I'm waiting for others. Okay, bye. Minashi, Muhammad Umar, Hishma, Astha. Okay. Look at your powers, Astha. Will it be 10? Okay. हाँ ठीक है. Now it's fine. Now fine. I read it wrong. Okay, Minashi. I see. You have to write it clear, Minashi, like what you have calculated in the first go. And I don't know why you don't calculate. You just write the formula and don't plug in the numbers. Try to plug in the numbers also, no? And I also think, Minashi, you have not done the assignment then.
I send it in WhatsApp.
You sent in WhatsApp
Yeah, to Niska, sir.
for this question? Yeah, I
No,
saw
I
that you have sent.
send it to Niska, sir.
Nishkar, sir? Sorry,
Yeah, the
Minashi.
assignment.
If you have my number, you have to send the assignments to me.
For the assignment, I send it to Niska, sir.
Nishkar, sir, is not working
Okay.
now in Learnivio also.
Yeah.
Okay, you send the assignment to me now. Just forward it here. You send anything related to chemistry, you will send it to me, or you will upload in the web portal. No one else. Okay.
Okay, sir.
For how many? For how long have you been sending that to Nishkar, sir?
Just today I send it.
Just today only. Okay. So Minashi, if you see the Hishma, what about you? You have not sent the answer. Did you send? No, you haven't. Yes, Hishma. Your answer is fine, Mohammed Zubair. I mean, but you have to take care of the decimal points. It should be at least 2 more decimal points there. Okay. So, Minashi, can you hear me?
Yes, sir.
See, you have written what? What is the first thing that you have to calculate? Rate of reaction, correct?
Yes.
Where did you calculate the rate of reaction? Did you calculate the rate of reaction?
Yeah. Yes.
Yeah. What is the rate of reaction? Tell me.
-1/2 delta A by delta T equal to.
But that is an expression. Calculate rate of reaction. It means you have to give an answer in terms of numbers, not as expression. Okay. Fine. So what you have written, you have, and also you have not written rate is equal to something like that. So what you have to make sure is that you write each and everything very properly. So rate will be equal to, all of these things are fine. 1/2 minus delta A upon delta T, which is equal to, now for B also you have written 1/2. Why is that? B does not have any coefficient now, Minashi.
You
look at your answer.
Yeah.
Got it? Okay. Now, out of all of these things, Minashi, tell me, what do we know?
Delta C, I mean C.
Delta C by delta T, we know. This whole thing we know. Why? What is this?
1.3 into 10 raised to minus 1.
This is rate of appearance, which is equal to 1.3 into 10 to the power minus 4. Now, then I can write it like this. Rate is equal to how much? 1 by 3 into delta C by delta T. And 1 by 3 into, what is delta C by delta T? It is rate of appearance of
1.3
C.
into
1.3
10
into
raised to
10
minus
to the power 4 moles per liter per second. Also, guys, you have not writing, some of the guys are not writing answers. You have to make sure that you write the answers also. So 1 by 13 upon 1 by 3, it will be equal to how much?
0.43.
Into 10 to the power minus 4 moles per liter per second. And not you have to calculate rate of disappearance of A. What is the rate of disappearance of A? Tell me. It is equal to?
Minus 1 by 2 delta A by delta T.
No,
equal to
no. No. Read the second point of the note of the last class. What did I write? Tell me. I think it was second point of the first point. Second point of the remarks.
The rate of reaction is mathematically defined as the rate of
Second point.
appearance.
Second point. That is the
The
third
rate
point.
of appearance and the rate of disappearance have nothing to do with this stoichiometric coefficient.
Correct. So rate of disappearance will be equal to
Delta A by delta T.
minus delta A by delta T. Minus sign will be there because it is disappearing upon delta T. Okay. Now, if this is equal to, then in this particular equation of rate, instead of writing minus delta A by delta T, I can write rate of disappearance. So I can write rate is equal to 1 by 2 into disappearance, and I can write rate of disappearance of A. It is equal to how many times rate? 2 times rate. Correct? Yes or no? Minashi?
Yes, sir.
What is this? Will be equal to 2 into what is the rate?
0.43 into 10 raised to minus 4.
0.43 into 10 to the power minus 4 moles per liter per second, which will be equal to 0.86 into 10 to the power minus 4 moles per liter per second. Okay. तो मीनाक्षी प्लीज एक बार हम आपका असाइनमेंट देखेंगे कि आपने कैसे किया इसमें, बट आप प्लीज कैलकुलेट कीजिए, आप एक्सप्रेशन लिख के मत छोड़ दीजिए. ओके, ट्राई टू कैलकुलेट दीस थिंग्स. Write note. So write this note. This will be used like in very some rare cases. See, for homogeneous gaseous reaction. For homogeneous gaseous reaction, rate of reaction is expressed. Rate of reaction is expressed in terms of change in concentration per unit time. Okay, so change in concentration can be used. We can use pressure also, but again, pressure is directly proportional to concentration. Whenever we say concentration, it means that we are talking about pressure only. Okay. But if we have a heterogeneous system, please write. For heterogeneous system, the rate of reaction is expressed in terms of change in number of moles per unit time. Okay. Also, we have known, and now we are going to write for a general reaction. For a general reaction, if I have AA plus BB giving me CC plus DD, then for this I can write rate is equal to 1 upon A minus del A by del T, which will be equal to 1 upon B minus del B by del T, which will be equal to 1 upon C del C by del T, which will be equal to 1 upon D delta D by delta T. So this is general. And now you are going to write the topic types of reaction, types of rate of reaction, average rate of reaction, and instantaneous rate of reaction. Average and instantaneous. Let me know when you guys are done.
So homogeneous and heterogeneous means what in this case, sir?
Homogeneous gaseous reaction means all of the, when you have everything in the same phase. Like if it is in aqueous phase, then everything will be in aqueous phase. If it is in gas, then each and every species in reactant and product, it will be in gaseous state. If I say heterogeneous, it means some of the species in the chemical reaction are in solid, some in gas. So there are different phases. So homogeneous means they're in all in same phase. Heterogeneous means they can, if any one of them is also different, then it is going to be heterogeneous phase. Okay.
Okay, sir.
Let me know when you guys are done. Done, everyone? Yes or no? Please tell me.
Yes, sir, done.
Okay. All right. Types of rate of reaction.
Sir, could you show those points one more time, sir?
Write it fast, but have you not written this? Yes, Nabil? Have you not written this? Types of rate of reaction. Number one is
No, sir. The video is going off and on, sir. Okay, can you just show it one more time, sir. Just catch a screenshot.
done.
Yes, sir.
Take this also.
Done, sir.
So you must have learned average speed and instantaneous speed. Similarly, we have average rate of reaction. And we also have instantaneous rate of reaction. So first of all, we'll learn about average rate. Please write the heading. Average rate of reaction. Okay, right here. It is defined as It's defined as the change in concentration of reactant or product in a fixed interval of time. In a fixed interval of time. Okay, so I have something like this. So for reactant, if I have I will have concentration here. Here I will have time. So tell me, reactant at time 0, there will be some reactant, yes or no? Or reactant will be 0 when we are starting? What do you think? We will have some reactant, yes or no?
No, sir.
We will not have any reactant. अरे भाई तो start कैसे होगा reaction?
Sir, what's the question? Can you repeat it?
I'm asking, will there be any reactant when at time 0 when we are starting the reaction?
Reactant or reaction?
Reactant. Will there be any
There will be.
reactant?
There will be. It won't be consumed at the starting. So there will be.
And starting it will be not consumed, है ना? ये circle वर्कल मत बना लीजिएगा please, ठीक है? So from the circle I am trying to draw the you must have heard about conic section, right? So from cone you can draw all the things in 3D. And if I want to draw majority of the plots, I can draw it from a circle. Okay. So just see. Okay, so this will be the plot for okay, Mohammed Umar. This would be the plot for the reactant, है ना? So initially reactant is something, but then by time what is happening, the reactant is slowly, it is getting over. Let me draw it in red. I think it will be better visually. Yeah. If I want to talk about the average rate, then I can take some points. So let us say this is time which is t1 and this is time which is t2. So in t2 we have something like this we can plot. So the concentration is somewhere here. And for t1, oh my god, I have to make a very large line somewhere here. Okay. So this is C2 and this is C1. I hope all of you can see. Okay, so rate that is average, it will be equal to final minus initial upon final minus initial. Obviously C2 will be smaller, as you can see. This part is C2. And so this whole thing will come negative. Rate can never be negative, so there will be a negative sign here as it. Similarly, I can draw the same thing for the products case also. Oh my god. Mosquitoes here. Oh, okay. No, not square. Okay, so how can I? Okay, why? What is this? What is this? I am selecting a vowel. Okay, I'm getting a vowel. Okay, so this will be the change in product. Something like that. ऐसा नहीं कि हमेशा increase होता रहेगा ना. The amount of product, it will get constant at some point, है ना? Get constant at some point. So this is concentration here. And this is time. Okay. And then again T1, T2, C1, C2. So let us suppose we have T1 here, and we have the T2 here. And just a second.
Sir, concentration of A will never become zero, sir.
Sorry.
The concentration of like the first reacting species, it will never become zero, sir.
I mean, theoretically speaking, no. But लेकिन वो इतना कम रहता है कि उसको measure करना possible नहीं रहता है. Okay. So that is why we say that it approaches zero. There is too much of noise, Nabil. There is too much of noise. Are you fine? Yes, Nabil?
Yes, sir.
Okay, okay. Okay. So this is C1, this is C2, and obviously here the C2 is larger. Here we have R average, which is equal to C2 minus C1 upon T2 minus T1. As simple as that. Draw these things. Let me know when you're done. Then you'll write about instantaneous rate of reaction.
Sir, will they ask us to draw these graphs in exam?
No, they will ask you to write the difference between these things: average rate of reaction, instantaneous rate of reaction. So it is better if you give them more and more points to give you marks. That is why
So we
this
can
is
plot these
important.
graphs.
Sir, could you like scroll up?
एक तो ना आप लोग स्क्रॉल अप मत बोलिए कीजिए, आप लोग बोलिए कौन सा टॉपिक. स्क्रॉल अप तो हम कहाँ चले जाए, बिल्कुल आगे चले जाए क्या? Let me know the topics, okay? Like, so just scroll a bit up, sir, like till average rate of reaction where you have started the topic. Can you go to the last topic, sir? Can you go to the starting of this topic, sir? Use these terms. That is why, so that it will have more clarity. All of you done? Yes or no? Please tell me.
No, sir.
Okay. Is everyone done?
Yes, sir.
Just a minute, sir. Drawing the graph.
जल्दी कीजिए, जल्दी. इतना टाइम तो ना लगता है. आप बैठ के देखते रहते हैं जब हम ड्रॉ करते रहते हैं तो. साथ ही साथ बनाने की कोशिश कीजिए, 3 बार बना लेते हैं हम अभी तक। कबीर हुआ? चलिए अब आप खुद से कीजिए। आई होप यू हैव अंडरस्टूड द ग्राफ, यू कैन ड्रॉ इट ऑन योर ओन। Okay, now write next. What color was I using? Instantaneous rate of reaction. If rate of reaction is calculated, rate of reaction is calculated at a particular instant of time, it is called instantaneous rate of reaction. Okay, so I will borrow these graphs only. Now, here obviously we are not doing this thing C1, C2 at time T1, T2, no intervals are there. Okay, so there is no interval like this. Now, now, at a particular instance, so let us suppose I want to calculate the rate at this time. So I will just plot here. Okay, so I've got this point and I need the slope of this point. So for the slope of this point, what I'm going to do, I'm just going to draw something as a tangent, है ना? अब जहां से भी tangent बन जाए वहीं का rate निकाल देंगे हम लोग, ठीक है? So we are not going to worry about whether I have drawn the tangent on that particular point or not. Okay, so it seems that I don't want to calculate the rate of this point. Rather, I want to calculate the rate at this point. Okay, so this point I want to calculate the rate. This is what delta t, and this will be my delta. Oh, what happened? Okay, so this will be my delta t. This will be my delta c. Okay, and here we'll write delta c upon delta t. This is equal to dx upon dt, which is equal to the tan theta, the slope. Okay, so we write this r instantaneous as dx by dt. Now, those guys who are wondering how are we going to draw for the product part. So same thing, we will draw some kind of tangent here, and this tangent is not touching somewhere. Okay, now it is touching. So I'm plotting for this one. What I need to do, I need to just make a right angle triangle out of it. Okay, so just hope that this is 90 degree. This is my delta T. This is my delta C. You can just plot here like this. Now, ये time आपको हो जाएगा delta T. I hope you can see that. Similarly, this will be your delta C. That's it. I mean, the use here is just for the case of ये. What do I say? Your differences between average rate and instantaneous rate, nothing else. Done, everyone? Yes or no? Please tell me. Is everyone done?
So one second.
Okay. G. Done.
Yes, sir, done.
Sir, angle theta refers to which angle, sir? Made with respect to concentration axis or time axis, sir?
You tell me which axis. Theta कौन सा होता है? Tan theta जब sin theta या cos theta जो भी होता है. That theta refers to which angle? Tell me. The one which is made by the perpendicular. I don't think you're fine.
Sir, can you repeat, sir?
I am saying that you tell me which angle. It refers to the base angle or like the base and hypotenuse or the perpendicular and hypotenuse. Whenever we draw a triangle, you must have drawn the triangles like this, right?
Yes, sir.
So this A or B नहीं याद आपको? थीटा आप लोग कब से पढ़ते आ रहे हैं?
Sir, A, sir.
Which angle?
A, sir.
A, right? है ना? Okay then.
Yes, sir.
है ना? So you just reverse that graph. It will reverse this one. This will be this angle here. Okay. That is tan theta.
Yes, sir. And sir, one more question, sir. In textbook at page number 99, they have given one question, sir. R instantaneous is 600 seconds. For that, they have taken two measurements, 0.0165 and
Wait.
0.013. Yes, sir.
Just tell me the page number.
99, sir.
99. Okay. 99. Tell me now what you are saying.
Sir, they got R instantaneous is at 600 seconds, which is minus of 0.0165 and subtracted from 0.037. Sir, how did they get those values, sir? Because they're saying they got from the question given alongside. But that question, that values are not called there.
They have got that from the graph. Look at the graph.
Yes, sir.
Can you see that?
Sir, but yes, sir. But in the graph, it's not so. It's not such a precise value, right, sir?
Yes, for sure it is not precise. And for sure I have not printed that. So you are not going to get those type of questions, by the way, okay? You will never get these type of questions that they have asked. You will get the values in form of a table, okay? But nothing other than that. And even
Yes,
though,
sir.
for example, if you are getting a table now, so how did they make the table? Tell me. How did they make the, how did they make the graph? From the table only, correct?
Yes, sir.
Can you make the same graph in a very precise graph paper? From that table, yes or no?
Yes, sir.
And then can you get the precise values also? Yes or no?
Yes, sir.
Anna? So that's it. Okay.
Yes, sir.
So right here, factors affecting rate of reaction.
Then should we learn these values, sir?
Which
How they
values?
got these? That are instantaneous in 600 seconds. At
अरे
250
भाई वो एक
seconds.
सवाल के
50
अरे एक सवाल के लिए वो आप कैसी बातें कर रहे हैं नबील? That is for one question, ना? That is obviously going to change if you have a different question, correct? Yes or no? The table is going to change, the plot is going to change, the values are going to change, correct? Yes or no?
Yes, sir.
Anna? Also one more thing, if you have doubt, like if I am teaching something of class, आपके पास doubt है तो यहाँ पे पूछिए. ऐसी किताबों के doubts आप या तो class के बाद या तो फिर आप हमें WhatsApp में message कर दिया कीजिएगा, okay?
Yes, sir.
ठीक है, most of the students don't know what you're even talking about, right? Factors affecting the rate of reaction. We are going to learn at least, like, first of all, we are going to learn about the concentration of reactant, temperature, and catalyst. Fine. So write number one, concentration of reactant. Number two that we are going to learn is about the temperature. And number three, we are going to learn about the presence of catalyst. Okay, now these are the topics that are mentioned in your NCERT that we have to learn. Okay, but there are some other topics also that we will touch upon. Right, the fourth one, which is going to be the nature of reactant and product. Nature of reactant and product. Right, the fifth point, surface area. This is specifically in the case of solids, if you have anything which is solid. And the sixth one is exposure to radiation. Exposure to radiation. Okay. All of you done? Yes or no? Please tell me. Wrote these 6 points.
Yes, sir, done.
Okay. Now, you're not going to write whatever I'm going to tell you here. When a reaction happens, the basic theory that we have is, if I have a molecule of A and I have a molecule of B, and they are both in the system and they are far apart, will they react if they are far apart? Yes or no? Please tell me. Let us suppose they are in
No,
different
sir.
containers only. They are not going to react. They are going to react only if we bring them together. Now, what happens what is the change that is happening place when we are bringing them together? What is the change happening place? Like, दोनों अलग अलग कंटेनर में थे तो रिएक्ट नहीं करते, were not reacting when they were in different containers. Why are they reacting if we mix them, if we put them into same container? What is happening? What do you think at molecular level?
Because the molecules come together.
Because the molecule, sorry,
Come
can you
together,
repeat that?
they
Because
collide.
collide, right?
The molecules collide. Yes, sir.
So until and unless they will collide with each other, we will say that the reaction is not going to happen. Reaction does not happen until and unless they are going to collide with each other. Now you guys tell me a few things. If they are colliding, that means the reaction will be fast. That means the reaction is going to happen. Initially, when they were in different containers, the reaction was not happening. So if the reaction is not happening, that means obviously I can say that the rate of reaction is what? 0, because the reaction itself is not happening. Now, when I am going to mix them together, bring them together, then they are going to collide and the reaction is going to happen. And if the reaction is going to happen, the rate will be there. And we can say the rate is going to increase, right? The rate is going to increase. Now, that means I can directly say that rate is directly proportional to the collisions. Yes or no? Please tell me, guys. Rate is directly proportional to the collisions.
Yes, sir.
Right? Okay. Now, if I increase the number of collisions, if somehow I increase the number of collisions, then I am also increasing the rate of reaction. I hope all of you agree. Now, in what ways I can increase the rate of increase the collision numbers? In a particular container, we can heat them up, right? Correct. We can heat them up. If I heat these things up, then A and B, they will be moving faster. And if they are moving faster, then they are going to collide with each other. Okay, they're going to collide with each other in more frequent.
Applying pressure, right?
Sorry?
Also by applying pressure.
You can also apply pressure that is going to reduce the volume and they are going to then collide. Okay. Now, the next thing that you are going to do is, next thing that we can do is we can increase the concentration. And when I say increase the concentration, please see here. Concentration is what? Concentration, it is equal to the number of moles divided by volume. I can increase the concentration by either increasing the number of moles or decreasing the volume. When you say to increase the pressure, that means you're decreasing the volume here actually, right? So that is meant and that is there when we increase the concentration. So when I'm increasing the concentration, I can either do it by increasing the number of moles of reactant or I can decrease the volume. In both of the cases, what is going to happen? The concentration is going to increase. If the concentration is going to increase, the number of collisions is going to increase. And if the number of collisions is going to increase, then the rate of reaction is also going to increase. Is that clear? Yes or no? Please tell me. Astha, Hishma, Minashi. Okay,
Yes,
fine,
sir.
great. Nabil Ahmed, you set something up because like there is a lot of echo from your side. Whatever I say, I hear that back when your mic is on. Usually your setup is fine, but today I don't know why. Okay.
So
Now
today
you're
I'm
going to-
using browser.
Why you are using browser?
Sir, my app is not working, sir. It's taking long time to open.
Okay. Okay, fine. So right here, we are going to first of all learn about the rate of reaction. And for that, we have we are first of all going to learn about the concentration of reactant and how does it affect the rate of reaction. And that was given initially by C. I can directly say the rate is directly proportional to the concentration of A, right? And they said, okay, fine. And if I have the two different, which is A is giving me B. A is giving me B. So I can say that the rate of reaction is directly proportional to the concentration of A. That is fine. Very good. That's okay. If I have A plus B is giving me C, then I will say that rate of reaction is directly proportional to A and it is also proportional to the B. That means if I have A and B, then if I can increase either the amount of A and either the amount of B, and both of these things are going to increase the rate of reaction. Is that clear? Yes or no? Please tell me.
Yes,
Yes,
sir.
sir.
Right? Okay. Now, if I have 2A giving me C, now you will say, sir, rate will be directly proportional to A. I will say no. It will be directly proportional to A square. Why is that? Because we write 2A just for sake of saving space. Now, if you look at this reaction from this perspective, you can see that it is more similar to the second reaction. Yes or no? Can all of you see that? Yes or no? Please tell me. It is more
Sir,
similar
can
to the
you
second.
say again?
What I am doing here, I have 2A. So instead of 2A, I'm writing A and A. So I will say that C, it is more similar to the second reaction. So I can say that rate is directly proportional to A and also the other reaction, which is also A here. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
And that is why I can write a rate is directly proportional to A square. So these were the initial thoughts of scientists who were working on the rate of reaction, and they gave, and obviously at that time, they were more importantly worried about the mass of the reactant. So they gave a law and they said that law is law of mass action. So please write law of mass action. This was the beginning. Okay. According to this law. अभी के लिए according to this law, the rate of reaction is directly proportional to the product of concentration of each reacting species, product of concentration of each reacting species. Also, right, at constant temperature. So if I have A plus B, it is giving me P, some product P. Then we can write R is directly proportional to the concentration of A. R is directly proportional to the concentration of B. And we can say that R is directly proportional to the concentration of A and the concentration of B. Now, in order to remove the proportionality sign, I will write a K here, concentration of A and concentration of B. What is K here? K is a constant, which is known as rate constant. Okay, and please write for a general reaction. AA plus BB, which is giving me CC plus DD. The rate is equal to K into the concentration of A to the power A, B to the power B. This is the rate expression according to the law of mass action. Is everyone done? Yes or no? Please tell me.
Yes, sir. Done.
No, this is not a rate law. This is not the rate law. Now, right next, the rate constant. Seen what is rate constant? I don't know how many times I have told this. Whenever we have to calculate, whenever we have to define a constant, then we define it by, like, wherever the constant term is there, we will have some variable. For example, A and B are variables, and we have this K constant term. So what I am going to do, I am going to turn this turn this variable as unity. If I take the concentration of A as 1 moles per liter, B as 1 mole per liter, then the rate of that reaction is equal to the rate constant. Is it not right now, Mohammed Umar? Not right now. Okay. But why are you asking? I will say that please ignore him. Okay, a rate constant. It is defined as the rate of reaction when concentration of all reactants, all नहीं लिखिए आप, each लिखिए, each reactant is 1 mole per liter. So we have R, which is equal to K, A to the power A for a general reaction, huh? B to the power B. Then if I have 1 and 1, then R will be equal to K. Okay, when A and B both are equal to 1. Concentration of A is equal to the concentration of B, which is equal to 1. So then at that time, you will have the rate which is equal to K. Right, rate constant is also called specific rate constant, specific reaction rate, specific reaction rate or specific rate of reaction.
So that last one is small r is equal to K or capital R, sir?
Smaller rate constant, rate of reaction smaller.
Which is equal to K, right, sir?
हाँ, it will be equal to K ना, इसको आप apply तो कीजिए.
Yes, sir.
At this particular instant, okay, not always. Right here. Characteristic of rate constant. Right, number 1. It gives an idea about the speed of reaction. Greater the value of rate constant. If now each and every reaction will have a particular rate constant. That constant will be specific to that reaction. So if we have a reaction whose rate constant is very high, then we will say that that is also having a high rate of reaction. Okay, the greater the value of rate constant, higher is the value of or rather I can say value of rate constant, faster is the reaction. Faster is the reaction. Second point. Different reactions have different values of rate constant. Different values of rate constant K. Third, the rate constant is independent rate constant is independent of concentration of reaction, of concentration of reactant. Number 4. Rate constant changes with change in temperature. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Done, sir.
Very good.
That's it.
See.
Sir, wait, last point.
Acha.
Sir, factors affecting rate of reaction at 7th point. Can you say again, sir? Factors affecting rate of reaction 7th point. छूट गया था.
7th point है ही नहीं उसमें तो क्या छूटेगा आपका?
Yes, sir, you said 7th earlier, sir. Factors affecting rate of reaction. So it was 3 points. Concentration of reactant, temperature, and presence of catalyst is in NCRT. And the remaining 3 points, we also should remember the 7th point, exposure, remaining current rates.
7th नहीं हो 6th ही है. Exposure to radiation.
Yes, sir.
6 points are there. There is no 7th point.
Yes, sir.
I mean, NCERT has touched upon these things, but they have not mentioned it as a topic. Okay, but these are also the factors which affect. But when you go to collision theory, they have like somewhere mentioned it here and there. Okay, done everyone. Yes or no? Please tell me.
Yes, sir.
Now let us check this. Whatever we have written, the rate of reaction is directly proportional to the concentration product of the concentration of the reactant. This is what law of mass action says. Now I hope all of you remember the nucleophilic substitution reaction. In that we learned about SN1. In SN1, what happens? We have Rx, and it is going to give me the first step, a carbocation, and X negative, the leaving group. Now this is going to be slow, and here the next step, R positive, will react with nucleophile, and it is going to give me RNA. This is going to be fast. So obviously the whole reaction, it will depend on this step, the first step. No matter how much you increase the concentration of nucleophile, no matter how much you increase the concentration of nucleophile, it is not going to affect the rate of reaction. Here the rate is only depending on what the concentration of haloalkane in this specific case, but substrate in general. Now these are some experimental evidences which said that the law of mass action, which is very simple, which is very elegant in the sense that it is simple. Simple things are always elegant, but it is not true. If it is not true, it is of no use. But that is the starting point where we all have to start. When I start thinking about a reaction, then we think, okay, fine, the things will collide. If they will collide more, then there is going to be more reaction, and then there is going to be a faster reaction. But in reality, not all reactions are so simple that two things collide and all of them are reacting. In this case, R positive and nucleophile are colliding, but R positive has to be made on its own. Okay, so see, these were some realities which led to a change, and that change gave us the rate law. So we'll write here rate law. I hope all of you understood that why the law of mass action is not very applicable. Yes or no, guys? Tell me. The simplistic, just tell me.
Say it again, sir.
I'm saying I taught you guys about SN1. In SN1, what is happening? Even though this is the reaction which is happening. Okay. In this, according to law of mass action, we can write it like this. Rate is equal to K into Rx in nucleophile. But we know that in SN1, what happens? Even though this is the reaction which is happening, but it depends how the reaction is happening. If the reaction in which the slowest step, it needs only one reactant. If the slowest step, it needs only one reactant, then we can say that that particular step, that reactant is the one on which the rate will depend on. It will not depend on the concentration of nucleophile. Do you guys remember this or don't remember this at all? Huh? Asta, Heshma, Meenakshi, tell me.
Yes,
Yes,
sir.
what about,
Yes,
what
sir.
about others? Yes, you remember it, right? So here what is going to happen? The rate is going to depend only on the substrate. And that is why law of mass action is not valid. Okay, it is not the true rate law. Now we are going to write the rate law. Please write the mathematical expression. And this rate law can only be derived via experimentation. If you remember, if you see the law of mass action, it can be derived theoretically. अगर आपको reaction पता है तो आपको आप rate laws को लिख सकते थे वहाँ पे, right? But that is not true rate. So please write here the mathematical expression. The mathematical expression in terms of concentration of reactant which actually determines the rate is called rate law expression. Okay, so for a general reaction, AA plus BB giving me CC plus DD. In this case, the law of mass action said, law of mass action, it said that rate will be equal to K into the concentration of A to the power A and B into the power of B. But rate law says the rate will be equal to K into the concentration of A to some power P that we don't know, and B to some power Q. Right here, P and Q may or may not be equal to A and B. देखिए यहाँ पे CS3 whole thrice attached to carbon, which is further attached to Br. Plus we have aqueous NaOH. So here you can say that obviously the rate is, so this is going to give me CS3 whole thrice carbon, and there will be OH plus NaBr. Correct. Now, according to law of mass action, law of mass action is going to say that rate is equal to the K into concentration of, I'm writing this as RBr, okay? RBr and also NaOH. Okay, but we know that this is what tertiary 3 degree, yes or no, please tell me guys. This is 3 degree, correct? Yes or no? Yes or no, guys? Please, I want answers from everyone. आधे लोग तो चुपचाप बैठे रहते हैं. हाँ, guys,
Yes,
me.
sir.
Okay, so if it is
Yes,
3 degree,
sir.
then what it will prefer? It will prefer SN1 or SN2. If it is 3 degree, it will prefer SN1 or SN2.
SN1.
SN1.
SN1, correct? Okay. If it is preferring SN1, and then we know that actual rate law. The rate law, it is equal to R, which is equal to K, and it only depends on the concentration of RBR. So its concentration to the power 1, and it does not depend on the concentration of NaOH. So I can write concentration of NaOH to the power 0. Can you see that? Yes or no? Please tell me. Now in this rate law, the P it is equal to 1 and the Q it is equal to 0. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
यहाँ पे आपके पास 1 1 था रेट है ना. यहाँ पे जो लॉ ऑफ मास एक्शन क्या कहता है, सिर्फ सीधा सीधा ये किस पे डिपेंड करेगा. It will now, can you see that this is the true rate and law of mass action is not true. Now if you look at this coefficients here, the P coefficient and the power here it is same, but for Q it is not same. So that's what I was saying, that P and Q may or may not be equal to A and B. And that is our main goal. Like we are going to do some questions in which we have to calculate the order of reaction. This is known as order of reaction. First of all, you write a note. Law of mass action. Is a theoretical concept. And associated with balanced chemical reaction. Second point, rate law is experimentally determined. It's very important. It is experimentally determined. It may or may not be. It may or may not. Associated with the stoichiometry of reaction. Stoichiometric coefficient. Stoichiometric coefficients. Done everyone? Yes or no? Please tell me.
Done,
Yes,
sir.
sir.
Right, next, order of reaction. It is defined as sum of power of concentration terms raised in rate law expression. So if I have AA plus BB giving me CC plus DD, then the rate law is going to give me rate law to say that R is equal to K into the concentration of A to some power P, which is not, may or may not be equal to A, P and B, which is raised to Q. You can write M and any other letters also, but these are not A and B exactly. Now in that case, order of reaction, it is equal to P plus Q. Sum of power of concentration term, powers of concentration terms in the rate law expression. Right here remarks. Number one, it is experimentally determined. It is experimentally determined value. Next point, it can
Sir, what is the topic again?
order of reaction.
Okay, sir.
It can be 0, positive, and fractional value. It determines the rate of reaction. Right, next. Right, the last part, it changes with external factor such as temperature, pressure, etc. Is everyone done? Yes or no? Please tell me.
Yes, sir, done.
Okay, now see, as we know that the rate law, it can be only determined experimentally, right? It can be determined only experimentally. Now, there are a few things that we can, there are a few types of questions that we are going to get. So we will write, first of all, determination of rate law and order of reaction, because both of these things are experimentally determined. Okay, we'll write here. देखिए यहाँ पे आपके पास क्या है, rate, it is equal to K, A to the power P and B to the power Q. Okay, so here what do we expect? क्या करते हैं हम लोग? Please listen to this very carefully, because it is going to help you make a framework for this chapter, what is happening in this chapter. Okay, now when you are doing a reaction, you know that reaction, it is going to be A plus B giving me C or D, something like that. Yes or no? Please tell me. Correct? You will know this, yes or no? Okay.
Yes, sir.
Will you be the first person doing this reaction? Tell me. If you're doing a particular reaction, no, right? Most probably you're not the first person doing this reaction. Now, if this reaction has been done already, then what is going to happen? You can get the rate constant, because if it is done already, that means people have calculated the rate constant for you. Correct? They have calculated the rate constant, and you can get the rate constant from some data booklet. Is that clear? Yes or no? Please tell me.
Yes, sir.
So,
Yes, sir.
right. So we already have K. No problem. And what is this in square brackets A and B? These are the concentration of A and B. Yes or no? Please tell me. These
Yes,
are the
sir.
concentration. Now, when I say that these are the concentration, I mean initial. When I say initial, then I mean to say that whenever you start observing it, ठीक है? जैसे मान लीजिए आपको रेट पता करना है, but you have started a reaction 1 hour ago only, right? 1 hour back you have started a reaction, but now you want to know what is the rate. Now at that time the concentration will give you the rate of that particular point. That is why now you started observing, so that is the initial state. Okay, it's very much like physics that you have studied. Like whenever it depends on when you're starting to look. Like if I ask about the initial velocity of anything, then u should be always equal to 0, but it is not always equal to 0. The u is not always equal to 0, right? That means whenever you start looking, that is the initial phase. Okay, so at this particular point, you will know what is the concentration of A and B, because you are starting a particular reaction. You will go there, you will weigh the amount of A, you will weigh the amount of B, then you can calculate the concentration of A and B. Is that clear? Yes or no? Please tell me. Yes or no? You know this also, the concentration of A and the concentration of B when you are doing a reaction. Correct? Are hi Anna, boliye please.
Yes,
Yes,
sir.
sir.
Yes, na? I hope everyone is with me. Now, the only thing that we don't know is this P and Q. We don't know this P and Qs. Okay, we don't know this P and Q. Now, we have to actually, whenever I say the determination of rate law, I have to determine a rate law for a particular reaction, question is asking. Then essentially, what they are asking is that you have to calculate you have to determine the order of reaction. What will be the value of P? What will be the value of Q? That's the only thing that you have to do. Now, obviously, in some question, you will be given the concentration of A, the concentration of B, the rate of the rate of reaction also. These things will be given, and you will be asked about the rate constant. Calculate the rate constant. But again, those questions are futile questions. Like experimentally, practically speaking, those questions are of no use. They're just there just so that you can juggle in the equation. You can find any value that is asked for you. But rate constant, you're not going to calculate the rate constant anywhere when you're doing science. You're going to the Google and you're just typing for a reaction. What is the rate of reaction for this particular temperature? Because it depends on temperature. Okay, that's the only thing that you're going to do. But in some question, you will see that you have been asked to calculate the rate constant also. But I hope you can easily see that rate constant should never be calculated. It should be just looked up, right? Yes or no? You can just look it up, correct? Yes or no? Tell me, guys.
Yes, sir.
Yes, sir.
Right. Okay. So please keep this in mind that we are basically trying to fetch the order of reaction. So see, determination of, just a second. Determination of the rate of reaction. Sorry, not rate of reaction. I should say rate law. And order of reaction. We're going to use a few methods. So since we are going to calculate the order of reaction, that is the most basic point that we have to calculate. We can calculate it by seeing the unit of rate constant. Unit of rate constant. Secondly, by experimental method. And thirdly, by mechanism of reaction. Mechanism का तो आपको पता चला होगा, SN1 का हमने अभी जब बताया. That means mechanism also give us some insight about a reaction. Mechanism of reaction. Okay, write these three things. We are going to learn about these in the next class. Okay. Is everyone done? Yes or no? Please tell me.
No, sir.
Yes, sir.
जल्दी इसको लिखिए. We are going to start with the unit of rate constant and how it tells us about the order of reaction. Yes, Mohammed Umar, you can leave. Okay. Done?
Yes, sir, done.
Okay. Sure. Thank you guys. Thank you very much. Bye bye. Take care. We'll meet on Tuesday now.
Thank you, sir. Allah Hafiz.
Who is saying that? Allah Hafiz.
In my sir, in my class they started electrochemistry, sir.
हाँ तो वही. अच्छा ठीक है, आपकी क्लास ने इलेक्ट्रोकेमिस्ट्री स्टार्ट किया है. तो आप ये बताइए.
Yes, sir.
आप I'm giving you 3 timings. Saturday and Sunday 4 to 6, or Saturday and Sunday 6:30 to 8:30. Thank you, Minashi. Or Monday and Wednesday 4 to 6. Tell me. Choose any one
Sir,
of these.
Sir, I have free on only Wednesday at 4 to 6 and Thursday at 6 to 8, sir. Otherwise, I have 2 classes every day.
See, Nabil, see, I am teaching electrochemistry in these classes. Note these timings down, please. Note these timings down.
Noted, sir.
Noted. Okay. हमको फोटो भेजिए तो आपने क्या नोट किया. ठीक है, हमको बच्चों पे एकदम भरोसा नहीं होता है. ठीक है, यू सेंड मी अ फोटो व्हाट यू हैव नोटेड डाउन. नाउ आप जहां पे भी जो भी क्लैश हो रहा है ना, यू हैव टू सॉर्ट इट आउट. लाइक आप सर से पूछ के देखिए कहीं और, लाइक दूसरे क्लास में, कि सर आप हमको शिफ्ट कर सकते हैं क्या. देखिए आज आपका क्या होता है, केमिस्ट्री होता है कब, ट्यूसडे एंड थर्सडे, राइट. 4 to 6 आपका केमिस्ट्री होता है. ठीक है, इस नबील
Yes, sir.
है ना. तो अगर आप इन तीनों में से किसी एक बैच में इस बैच में चले जाइएगा, किसी तीनों में से किसी एक में, तो ये आपका फ्री हो जाएगा. करेक्ट. यस और नो.
Yes, sir.
ठीक है, तो आप अपने टीचर से पीछे कहीं पे भी अगर क्लैश हो रहा है तो कैन दे शिफ्ट यू टू ट्यूसडे थर्सडे 4 to 6. ओके, आई हैव गिवन यू 3 choice. आई थिंक 3 choice इज गुड इनफ, है ना. यस और नो.
Yes, sir.
है ना. तो आप पूछिए कहीं पे भी क्लैश हो रहा था. तो आपकी ना आवाज सही से नहीं आ रही, इस वजह से हम आपसे ज्यादा बात नहीं कर पा रहे. आप जिस भी टीचर के साथ क्लैश हो रहा है, आप उनको क्लास में बोलिए कि सर कैन आई बी शिफ्टेड टू ट्यूसडे थर्सडे 4 to 6. किसके साथ क्लैश हो रहा है, कौन से सब्जेक्ट के साथ, बताइए. व्हाट डू यू हैव ऑन सैटरडे संडे 4 to 6, नबील. व्हाट डू यू हैव ऑन सैटरडे संडे 4 to 6?
Sir, I'm having Saturday. I'm having maths and biology, and Sunday I'm having physics and biology, sir.
आप लर्निंग में नहीं कर रहे हैं सारी क्लासेस.
Learnivio में ही, sir.
तो मैथ्स आपका एक दिन होता है क्या. हाँ नबील. आवाज नहीं आ रही आपकी. अच्छा ठीक है, जिस भी टीचर से हो आप उनसे पूछिएगा. तो मैथ्स और बायोलॉजी फिजिक्स और ये कर रहे हैं, तो मंडे वेंसडे क्या कर रहे हैं आप. हाँ नबील, मंडे वेंसडे.
सर वो एग्जैक्ट टाइम टेबल मेरे पास नहीं है, सर.
है एग्जैक्ट नहीं, मंडे वेंसडे आप कोई क्लासेस होती है.
हाँ सर, होते हैं, मगर जो क्लास होते हैं नहीं मालूम है, सर, क्योंकि वो टाइम टेबल नहीं मिला, सर. वो जो लिंक भेजते हैं उसकी तरफ से मैं ज्वाइन करता हूँ.
अरे भाई मेरे, तो आपने अभी तक टाइम टेबल ही नहीं बनाया. आपने जब भी आपको जो लिंक मिलता है आप ज्वाइन कर लेते हैं.
सर
नहीं, ऐसे तो ही ना चलेगा काम. आपको पता होना चाहिए कि कौन से सब्जेक्ट की क्लास होने वाली है. आपको जो लिंक मिल रहा है आप आ जा रहे हैं. तो आपके पास टाइम टेबल मंडे वेंसडे आपको नहीं पता कुछ होता है या नहीं होता है.